We're going to continue our examination of large-scale atmospheric processes that'll help us to understand a bit more about the weather and also to help us with some short-term forecasting. We'll start with air masses. Having an understanding of air masses helps us to have a general understanding of the weather that we're experiencing at a particular time and the weather that we might experience in the coming days or extending out to a week or 2 weeks. All right, so what is an air mass? So an air mass is a big amount of air with similar temperature and humidity. Now, do you remember when we looked at air parcels? It's a similar sort of concept, but the main difference between air parcels and air masses is scale. So an air parcel, as we saw before, is an amount of air that has similar temperature, humidity, as well as other characteristics as well. Whereas an air mass is a much larger body of air, and we simplify its definition by just saying it has similar temperature and humidity. Other features could vary more widely. The general categorization based on size is that an air mass is a minimum or around about 1 million square kilometres. And to put that into context, Australia's land mass is about 7 million square kilometres. So it's a very large amount of air. So it extends horizontally, but also extends vertically right through the troposphere. So it's an air mass, and if it extends all the way to the troposphere, then it clearly has a major impact on the weather. It is the weather that you would be experiencing. Okay, so the conditions that you find in an air mass depend upon two things: where it came from and where it's been. And we'll look at both of those in a minute. Now, the boundary between two air masses is what we call a front. And you've all heard of, and if you've been doing the practical workbook, you've been dealing with fronts. Okay, so the conditions you find in an air mass depend upon its source. So wherever that air mass exists, it will take on the conditions that exist at that location. So it'll collect its temperature from where? Well, predominantly from the temperature of the Earth's surface. Generally, it takes quite a while to warm up an air mass, and predictions or estimates are that around 1 week to warm about 10 degrees centigrade. And in order to do that, the air mass must be stationary or moving very slowly so that it can take on the conditions that are existing at that point on the Earth's surface. There are two main source regions. We saw a little bit of this when we talked about differential heating of the Earth and the Hadley cells and Ferrel cells and the major air circulation of the Earth. And so the two major source regions are 30 degrees north and south of the equator, and these are our high pressure cells, bands of high pressure, and they produce more tropical air masses because they're close to the tropics. And then the other major source region is 60 degrees north and south of the equator, and those conditions there, because they're much closer to the poles, we say they take on polar conditions. Okay, so we've introduced two terms there. Let's look at that in more detail. So you can classify the air masses of the world based on quite simple terminology. And here we have a map of the major air masses around the world, and you can see those two-letter symbols there. All right, what do they mean? Well, the first way you can classify air masses is simply whether they're polar or tropical. And just with those two terms, if you've got a polar air mass, well then you think, oh, it's going to be colder or cool. And if you've got a tropical air mass, oh, so it must be a warm air mass. And it's as simple as that. You then further define those air masses based on, again, the source region or their characteristics, and we add to that terms maritime and continental. Maritime, what does that mean? It means over the ocean. So if you've got a maritime air mass, it's likely to be very humid. If you've got a continental air mass that's been moving over or coming from the centre of a continent or predominantly over land, because there's less water over land than there is over the ocean, it's going to be much drier. And you put those two terms together to give us those major names of air masses. So continental polar would be what? It would be a dry, cold air mass. Maritime polar would be a humid, cold air mass. Continental tropical, dry, warm. Marine tropical, maritime tropical, it would be wet and warm. Now, many countries then further define their air masses a little further to give them more geographical names, and in Australia we have extra names that we give to them, such as equatorial or Indian, just to denote it's coming from the Indian Ocean, Pacific from the Pacific Ocean, Southern from the Southern Ocean. And these are our major air masses, and you can see the different names and where they come from and the parts of the continent that they predominantly affect. Given that we're so far north, the true polar air masses we don't generally come in contact with. Very rarely we do, but we certainly have cold air masses, and so there's a grading of the boundary there between those two names. So we have our major names of our air masses, and sometimes they're modified a little bit further, predominantly to denote where they've come from. Okay, so we've said that air masses take on the characteristics of the place that they come from, but then of course they can also change their characteristics as they move over different parts of the Earth's surface. And it's pretty straightforward. If you start off with an air mass that is cool and it's moving, let's say it's moving north and moves over warmer areas, let's say it's moving over a hot continental area, then it will take on those characteristics. So if it starts off as a dry, cold air mass and moves over a warm continental area, the humidity won't change much in the air mass, but its temperature will, and so it'll become a warmer air mass and may then transform into a continental tropical air mass, for example. Similarly, if you've got an air mass moving over an ocean, so perhaps it's going from the continental area onto the ocean, then it was originally a dry air mass, and as it moves over the ocean, because of evaporation, takes up some of that moisture vapor over the ocean and becomes a more maritime air mass. So two ways that air masses take on their characteristics: the area that they came from, their source region, and also the journey over new areas that then give that air mass different characteristics. And we call that air mass modification. The important thing to note is that in the warming or cooling of these air masses during modification happens from the bottom. Why does it happen from the bottom? Because, as we saw many, many weeks ago, that is how air close to the Earth's surface takes on its temperature. If it's a warm, as the incoming solar radiation comes in, it will warm the surface, and that'll warm up the air that's above it. And also, if it's a colder area, then it'll take out some of that heat. So air masses change their temperature from the bottom up. Now this has a major impact on the stability. Okay, you should know what stability is. And so if an air mass undergoing modification is heated from below, so it warms up, that means that air mass will what? It'll rise. And we know that rising air means you have an unstable air mass. But if that air mass is cooled relative to what it was before, then it'll tend to sink and it will stay more stable. So it has real implications for the types of weather that you get. And we'll look at that in a minute. So air masses have a major role to play in frontal systems. So if you've been doing the practical workbook, you would have come across fronts and weather maps, and you know what a front is, such as this diagram here. You can see from a weather map, and you can see how they move in Australia, predominantly from west to east. Or if you happen to be looking at the rain radar when it's raining, sometimes you'll get these sort of bands of clouds extending and moving across the landscape. These are both representations of fronts. So let's have a look at fronts in a bit more detail. So we've said that a front is the boundary between two different air masses. Very simply, cold air that comes into connection with warm air. So if cold air is replacing warm air, we call that a cold front. If it's the warm air that's moving and replacing the cold air, we call that a warm front. So let's have a close look at cold and warm fronts. So the weather that you will experience, let's start with a warm front. As a warm front approaches, it'll move up and over the cold air. What that does is produce different types of clouds in a more gentle manner, if you like. So you will start, as the warm air rises, depending on how much moisture is in it, it'll reach its dew point, and the clouds will slowly develop as that air starts to rise and move up over that cold air. So you'll generally start with nimbostratus clouds, and then they will change depending on where you are in the front up to the cirrus clouds in the highest part of the atmosphere. Generally speaking, you get relatively gentle rain, not many thunderstorms occurring as that warm air gently moves up at a relatively low angle over the cold air. Cold fronts are quite different. Cold air, as it's moving, will stay close to the Earth's surface because it's cold, and as it hits that warm air, because the cold front is moving, it will want to move under that warm air and will push up that warm air very, very rapidly. So often with a cold front, you'll get much greater clouds forming much more quickly over a much thicker part of the atmosphere, and cause clouds to form very quickly and often create thunderstorms and more intense rainfall. Depends on the relative differences and, of course, the moisture content in each of those air masses. But generally speaking, a warm front, which we don't often have in Australia, you have more gentle rain, but a cold front, you generally have more rapid development of clouds and more intense rainfall. So I'm just going to finish this lecture by tying in air masses, fronts, and one of the things we've looked at before, which is pressure systems. And you can have a look at this fabulous website, and you can see the high and low pressure cells there, and showing in this animation is real-time forecasted weather and wind movements. And you can see here, if we look at the velocity of the air movement, that the air is moving much more quickly where those isobars are closer together compared to where they're further apart. And you can see that they are moving anti-clockwise around that high pressure cell, and they move clockwise into the low pressure cell. Now, if we relate that to air masses, let's change the colour from velocity of wind movement to temperature. Now we can see the temperature of the air, and you can see that the air that's moving from the south is cooler, and as it moves up over the continent, it gets warmer, and air moving from the north then is warmer. So that air, those air masses, as they're moving from the southern maritime, it moves up over the continent, it'll warm up and will also dry, and will turn into a continental tropical. And you can see as it now moves, as that air moving south, you can see it's much, much warmer. So it's a really good demonstration of the role of pressure systems, and of course air movement, okay, which is driven by differences in pressure, can modify the air masses. So that's why it's good to have an understanding of air masses and how they are modified and how they relate to the movement of air around pressure cells. Okay, so that's our discussion on air masses, fronts, and pressure cells.